Sound is all
around
us.
Of all the sounds that we make or hear, human speech is one of the most important in daily life.
As well as speech, the noise we hear is all part of our environment. Be it a buzzing city or a relaxing countryside. Sound also conveys emotions, such as in a piece of music. Let's discover now how audio technology can help us to interact with the rich three-dimensional soundscape all around us. Although what we hear is a complex mixture of sound sources, we are able, without much effort, to extract meaningful information. We sometimes take this wonderful ability for granted, but to really understand how we hear, we need to understand first what sound is. Sound is composed of acoustic pressure waves that propagate through the air. The frequency of these sound waves determines the pitch of the sound, and the amplitude of the sound waves determines the loudness. The sound waves are reflected by surfaces, such as the walls or ceiling in a room, and these reflections are perceived as reverberation. After reaching our ear, sound waves are sensed by a biomechanical transducer in the outer and middle ear, and then our inner ear transforms this input into electrical signals, which are transmitted to the brain. And that's the most amazing part.
The human brain has quite astonishing abilities that allow us to process signals received at our two ears in order to recognize voices, words, and acoustic events, and to determine the location of sound sources in the room around us. Still, when noise and reverberation are present, speech intelligibility and speech quality may be degraded.
In our research, we derive mathematical models of speech, noise, and reverberation, and use these models to develop signal processing and machine learning technology that can improve the operational performance of a wide range of devices that we use every day, such as phones, laptops, or aids for the hearing impaired.
As current mobile devices and computers do not have the highly developed cognitive abilities of the human brain, researchers can compensate to some extent by equipping these devices with not just two, but actually many more microphones instead.
The number of microphones can be tens or hundreds in some prototype systems, such as this spherical microphone array, or even in robots, so that the robot can hear better in real-world situations.
Some of the techniques that we research combine the signals from the individual microphones in a way so as to select the sound coming from just a specific direction. And this type of spatial processing is what we refer to as beamforming. With it, we can create acoustic zoom, so that one could listen to a sound source far away and hear it as if it were much closer.
In order to interact in an intuitive way with a wide range of devices, including robots, computers, TVs, and phones, we want these devices to understand our speech. This kind of machine hearing process is known as automatic speech recognition. Our research aims to develop technology to give our everyday devices the same level of awareness and understanding, or even superhuman capabilities. Using multiple microphones is of key importance in our research. This helps machines to learn awareness of the soundscape in 3 dimensions and enables people and machines to interact with sound in a 3D world.